So looking at section 5, we're talking about solving logarithm equations and how you solve logarithm equations. You might have a problem like this. Is you're going to switch it to exponential form, but in order to do that, kind of the best way to do it is first to make one single log, just like exponential is you kind of get the base by itself. So here we want to make one single log. So notice we have two of them. And then we want to switch it to exponential form, and then we can go ahead and solve our problem. Here's a little bit complicated one. Let me give you the easier one. Okay, so this problem on the right is a little bit easier. Notice that we only have one single log with base 2, and we're taking the log of x cubed minus 19. And we want to find out what is the x value that when we take the log with base 2 of this number, we get 3 as an answer. So first thing, because the log is by itself, we can really just switch to exponential form. So we go ahead and use our base, and then these two switch spots, right? 2 raised to 3 equals x cubed minus 19. Now we can just go ahead and solve. 2 to the third is 8. And then I can add 19 to both sides. And then we get 27. And so what cubed is 27? That would be 3, right? Or I can cube root both sides. And when I cube root a number or fifth root a number, remember it's not plus and minus, just whatever the number is underneath the radical, the sign of the number underneath the radical. So x equals 3, right? And we can plug that back in. Make sure on your logarithms that you always plug your answers back in, because we can never take the log of 0 or any negative. So I need to plug this back in, make sure I don't get a negative here. So 3 cubed, 3 cubed would be 27. 27 minus 19 is 8, and then log base 2 of 8 is 3. All right, 2 raised to 3 is 8. So that's kind of an easier one when the log is already by itself. Let's look at a more complicated one. Okay, so here's a little bit more complicated, not too bad. Remember, it's ln, and ln is just a natural log, so this could be rewritten as 7 times log base e of x equals 28. All right, so we want to get the log by itself first. There's 2 ways to do that here. You could take this and write it as an exponent if you want to up here, and then the log would be by itself, and then we can switch it to exponential form. So that's probably the way that you might do it. So then this is what I'm taking the log of, right? So again, with ln, the base is e, so e raised to what is x to the 7th. So e raised to 28th is x raised to 7th. Now how do we get rid of the x to the 7th? I could 7th root that, right? Or remember, I can rewrite these as fractions. So e to the 28th, x to the 7th. I can raise this to the 1/7 power on both sides. Right, 1/7 power. So that's e to the 28 over 7 equals x to the 1st, because when I raise powers to powers, I multiply, and 7 times 1/7 is 1, right? And then that's e to the 4th, so this is e to the 4th equals x. So you can type that in the calculator and whatever that number is. Okay, so if we go back to the beginning here, 7 times ln of x, this might be a lot easier, right? So I'm multiplying my log by a number, so I can get rid of that by dividing by 7 on both sides, right? 7 over 7 is 1, so we just get ln x equals 28 over 7, which is 4. So now it's easier to change into exponential. E to the 4th equals x. So that one's probably a lot easier, right? Get the log by itself by dividing instead of rewriting it as the exponent. So that's definitely an easy answer, but both ways are the same. Okay, so here's kind of the more complicated one. Remember, it's just log here, so that is base 10. So these are both base 10. And since we're adding logs, we want to multiply what we're taking the log of, right? Then we can put it under one single log with base 10 here. So we can go ahead and multiply these two, so we get 3x squared minus 3x plus 2x is minus x, and then 2 times -1 is -2, and that's what I'm taking the log of, right? So like I should really put that in parentheses, because that's what I'm taking the log of, and that equals 1. If I don't put that in parentheses, it looks like I'm taking the log of 3x squared and then subtracting x after that, and then subtracting 2 after that, but I'm not doing that. Okay, so now we can switch to exponential form because this log is by itself. Right, so my base is 10, so 10 raised to 1 equals 3x squared minus x minus 2. Now it's a quadratic, right, because I have quantity squared though, or there. And I can solve this by setting it equal to 0. We subtract 10 on both sides. And then we can either factor it or we can quadratic formula, completing the square, any way to solve quadratics, right? You could graph it and you look for the x-intercepts. It's another way that you can do it. Here, like, you can factor it a lot easier because 3 times negative 12 is negative 36, and I'm adding it up to my middle, which is a negative 1, right? This is cab. C times A, what adds up to B. And because this is negative, that means I'm really going to be subtracting. So what times what is 36, but subtracts to negative 1? And that is what? Oh, this one doesn't work, right? Because 6 and 6, so this one actually doesn't work. It's not going to do cab, so we have to do quadratic formula. So that is our negative b plus or minus the square root of b squared minus 4ac. So negative 4 times 3 is a negative 12. Negative 12 times a negative 12, right? Our c is negative 12, so that's a positive 144. All over 2 times a, so over 6. So our x is equal to 1 plus square root of 145 all over 6. So there is our x so far. And we can kind of simplify this. Remember, you're doing a log, so we should always go back and plug in our answer to make sure that it works. And why I only did a plus here is because if I do just square root of 144, right, which is really close to 145, it's 12, and 1 plus 12 is 13 divided by 6. So that's a little more than 2, right? So 2 point something. And if I put 2 point something back into the original, this is going to be positive, right? And this one will 2 point something is still going to be positive, and I can take the log of a positive. So even though I'm not checking it all the way, I know that this positive one, this positive one right here will probably work. But the negative one, I get 1 minus 12, which is negative 11, right, over 6. So it's a little less than 2, negative 1.78 or something like that. So a negative 1.78, when I plug that negative in here, this is going to be negative, right? So since that's going to be negative, I can't take the log of a negative number, so that plus or minus is not going to work, right? Just the plus one. So this is my correct answer, and you could leave it just like that. That'd be fine. Or you can break down the 145, or you can get the decimal, but only the positive one is going to work here. Okay. Here's one that looks really complicated. In reality, it's not going to be as complicated, but since we have one log on one side and another log on other, or a couple logs on another side, basically, as long as I can get down to ln of something equals ln of something else, that means what I'm taking the log of, if I'm taking the log of both sides with the same base, then what I'm taking the log of each should also be the same. It's the same rules as, if the bases are the same, right? If the bases are the same, that means the exponents have to be the same, right? Same thing here. If the logs are the same on both sides, then what I'm taking the log of has to be the same. But first, I need to combine these two logs into one. Okay, so the logarithm properties apply. We just talked about on the last example, like when it's adding here, that means we multiply by what we're taking the log of. But when it's subtraction, we want to divide, right? So just remember that when there's subtraction, you want to divide. Now, by what I'm taking the logs of. Now here we can actually simplify this, probably without doing that so much, right? Because here I'm taking the log of ln, I'm taking the ln of e raised to the ln of x. So here I can deal with my log properties. Right here I have an exponent, I can move that out front. So that would be ln of x times ln of e minus ln of x minus 3 equals ln of 2. Now here ln of e, remember, equals 1, because that's log base e of e. And e raised to what is e? That would be 1, right? So this is 1. So now it just becomes ln of x minus ln of x minus 3 equals ln of 2. And that's not an exponent there. Okay, so again, I still have to use my properties of logarithms, say, hey, when you have a negative here, you have to divide by what you're taking the logs of. So the second one is always in the denominator, and we keep it under that with the same base, right, ln. Now, oops, trying to do shortcuts here, ln 2. Okay, so now the logs are on both sides, right, and it's the same log, so what I'm taking the log of also has to be the same. So x over x minus 3 has to equal 2. And then we do have a restriction here, right? X cannot be 3, because then we would get 0 on the denominator here. But we can multiply both sides by x minus 3, right, to get rid of that denominator. So then we get x equals 2x minus 6. Now we can go ahead and solve this. You know, you can add 6, subtract x. So we get 6 is equal to x. So there's our answer, but we want to make sure we check that, you know, especially with the logs. So 6. So we can put a 6 in here. We see we get a positive, right? We put a 6 in here. It's a positive. So we're really okay there. And then we can simplify that down to this one, right? This is 6. And ln of 6 minus ln of 3, right? So ln of 6 minus ln of 3. You can actually do that, right? You can use the properties of logarithms, say when I subtract two logs with the same base I divide, so that'd be ln of 6 divided by 3, which is ln of 2, right? And that's the right side, ln of 2. So we're good. So the correct answer is x equals 6. So those are kind of the harder ones of these type, but you can look in your book and it kind of gives you some solving exponential and logarithm equations and kind of the steps to kind of do that. But basically, if you want to get the log or the base dealing with exponentials by itself first, once you have them by themselves, then you can go ahead and once you have those by themselves, then you can go ahead and either, if it's a log, you switch to exponential. If it's an exponential, you usually take the log of both sides, right? And then you can solve for x. And then I would make sure, especially on logs, to go plug back your numbers back in to see if you get a log of a negative or a log of 0, because that answer is not going to work. Okay, so your homework for these starts on page 447, and the numbers will be, I'll write those down for you. Okay, so page 447, 35, 43, 47, 63, 71, and 73. So I'll go ahead and start doing these. You know, number 35, 5 ln of x equals 10. Get the base by itself, and then you can go switch to exponential form. Some of these ln problems, you might have to switch it to the different forms a couple times, based on kind of how you do it. And so like this one, now we can switch that to exponential form. ln is base e, so e raised to the 2 equals x. So you can leave your answer like that, or whatever that number might be. Number 43. So here's a log for you. Another one. Now remember, you're taking the log with base 4 of x cubed plus 37. So this quantity is what's being taken the log of, and that equals 3. The log's by itself, so we can switch that. And so then you can, that's 64. Then you're going to subtract 37. So that's what, 54, 24. And then you can cube root both sides. And so x is equal to, make sure on, actually on the first one I should have checked my log, right? This is a oops. This right here is a positive number. And that's already positive, so it should be fine. This one, the cube root of 24. Since 24 is positive, that means this is going to be positive when I cube root it, and I plug that number back in, and it's going to be fine there. And you can see the cube root of 24 being cubed is just going to get 24, and 24 plus 37 is not, that'd be 50, that'd be 61, so it should be 7, right? 27. Yeah, 27. And cube root of 27 is 3. So our answer, x equals 3. And that is correct. Okay, some of the other ones. Okay, so here's number 47. You're taking the log with base 3 of x plus 5 times the quantity x minus 3. And that's what you're taking the log of that product, and it equals 2. So we can go ahead and multiply those, or you can keep them separate for now. You can change this, since we're at one single log, 3 raised to 2 equals this product, right, of these two binomials. So that's x squared plus 2x minus 15 equals 9. Subtract 9 on both sides, we get x squared plus 2x minus 24, right? And is there factors of 24? What times what is 24, but subtracts to 2? That'd be, what, 6 and 4? So that, oops, that is x minus 4, x plus 6 equals 0, so that means x equals 4, and x equals negative 6. Now again, since you have logs, plug these back in, and negative 6, so this would be negative 6 plus 5 is a negative 1, and negative 6 minus 3 is a negative 9, and these are being multiplied, so that's 9, so we're okay, right? That negative still works on number 47. And then we can also check 4, plug in 4. 4 plus 5 is 9. 4 minus 3 is 1. 1 times 9 is 9 again. So we're good there. So 47 does work. Now we can look at number 63. So number 63. So here we have more than one log. So we can combine these logs first. X minus 21 equals log 100. And this is not, that x is not a base. Sorry about that. There you go. So that is number 63. So here we can combine these logs. Since we're adding, that means we're multiplying. So we're multiplying this. And keep it under one single log. And now we can go ahead and actually literally multiply those. And this would probably need to be in brackets like that if I left it like that. It'd be x squared minus 21x. Log of that. And now since the logs are the same, what I'm taking the log of also must be the same. So x squared minus 21x must equal 100. Now don't try, the only way you can solve this is quadratically, right? So I can't try to divide by x on both sides or subtract x or something like that, because if I divide by x, this 100 is eventually going to get divided by x, right? So we can't do that. So we can go ahead and subtract 100 on both sides and think what times what is 100, but then subtracts to negative 21. And so that would be x minus, or x plus 4, x minus 25, and then 25 and negative 4. So then I'm going to check these. Negative 4, so negative 4 here, boom, that's not going to work, right, because we have a negative in there. So that is not going to work, so only 25 is going to work, right, because 25 is fine. Is fine here, and 25 is bigger than 21, so we're good there. Alright, the last two, number 71 and 73. So 71, again, we have more than one log, so we want to try to combine those logs first. And notice that we're adding those logs, so that means we need to multiply, and we multiply these two binomials. Since there's an x in both of them, that means we're going to get a quadratic, right? So log base 2 of this quadratic, 2x squared minus x minus 3 equals 1. Here you can try to factor, use CAB. So you have negative 6. What are the factors of negative 6? That adds to negative 1. Or negative 1, not negative x, because that's your CA, and that's your B, and that is a negative 3 and a positive 2. But then since we multiplied C times A, that means we have to divide by our A, and our A is 2. And then we can just take the opposites of those, right? So x equals positive 3/2, and x equals negative 1. So we need to check that negative and the positive there, 3/2. So 3/2 in here is pretty fine because those cancel out, so we get 3 minus 3. That is actually 0, right? So that one's not going to work out. And neither is the negative one there. So let me make sure that I have this problem right. Oh, I don't, because I didn't switch it to exponential form, right? First. So we're not going to use these numbers, right? Because I got to switch to exponential form before I start using these and plugging those back in. So it's a base 2, so switch to exponential. 2 times 2 raised to the 1 equals 2x squared minus x minus 3. Now I have to subtract 2 on both sides, so that kind of changes that. Now are there factors of negative 10 that add up to negative 1? And it's only 2 and 5, right? So this is not going to work. So I have to use quadratic formula. So we do our negative b plus or minus the square root of our b squared minus 4ac, which is 40, over 2 times a, which is 4. And so we get 1 plus or minus the square root of 41. And that doesn't break down to 4, so we can go ahead and plug this into our calculator and see kind of what the decimals are and check those. Square root of 41 is bigger than the square root of 36, and the square root of 36 is 6. So I'm just going to kind of estimate here. 1 plus 6 is 7. 7 over 4, is 1 point something. Not quite 5. Let's go ahead and just do that. 7 divided by 4. So 1.75. And if I plug 1.75 in here and times that by 2, you get 3.5, and 3.5 minus 3 is positive, and plug in that positive here, I'm going to get positive. Okay, what about the negative one? So that'd be 1 minus 6, that'd be negative 5 over 4. And remember, these two are just kind of estimates here, so they're not actually answers here. So 5 divided by 4 is negative 1.5. So negative 1.5 times 2 is a negative. So this is going to be negative here, so it's not going to work, and it's a negative here as well. So that's really not going to work because I can't take the logs of those two negatives. So it's only the plus. So let's keep doing that. Just the plus here, right? So that's my answer. And if you have the decimal for that, that's great. Or you can leave it. You can leave it like that. All right, let's look at the last one, number 73. So number 73, dealing with ln of e raised to the x minus 2 ln of e equals ln of e to the 4th. We can use our properties of logarithms to rewrite these exponents. All right, so this is x ln of e minus 2 ln of e equals 4 ln of e, and ln of e is equal to 1, so this x minus 2 equals 4. We can add 2 to both sides, we get x equals 6. We can go ahead and plug that back in. And 6, we're fine there, right? Because we're all positive here. So, and you can bring that out here. This is 6. 6 minus 2 is 4, right? So really, you can just check it here. So that is our answer. Okay, so that's it for this video. Next time we'll look at applications.